Well, everyone, it seems like quite many have joined us now. So welcome, everyone. My name is Magnus Melander. I'm co-founder of Things, the deep tech hub in Stockholm. We created 6 years ago. We created Things to transform, learn how to transform innovation in small, sharp companies to value creation in large organizations through collaboration. And that's been going on for 6 years. And we focus on things that are more difficult, let's put it that way. We focus on industry, infrastructure, utilities, and mobility. We started Things, which is, by the way, financed by ourselves, so it's not funded by government or anything like that. We founded Things on the idea that larger companies, and they have, by definition, been very good at their own domain. Otherwise, they would never have grown large. But these days, with the very rapid technology development, not the least in areas like artificial intelligence and so forth, it's very hard for the larger companies to stay on top of their own domain. And it's even obviously worse to stay on top of what's happening around themselves. So they need, we believe, they need smaller focused companies to help them navigate through technology opportunities. And smaller companies in those fields, they will have difficulties scaling up and growing by themselves because it's going to take too long time. So we believe that they have to find ways to collaborate and work with larger companies to become bigger and more successful. So as of today, we have something like 130 Swedish Things members and alumni, and 45 what we call Things Enterprise Circle members that are corporates. The members of Things Enterprise Circle are about 1/3 are international and 2/3 are Swedish-based companies. We started all our efforts to figure out how to actually meet in a good way. And we practiced that for 2 or 3 years with primarily what we called workshops at the time, where a large company asked us to create the workshop for them for something specific, and then we invited 5 or 6 smaller companies, relevant companies, to that workshop. And after 3 years, we spun out that to something you might be aware of called Ignite Sweden, which is a national platform for actually matchmaking between small and large companies. Very, very successful. I think they've done 3,500 or so meetings between a large and a company and a small company over the last 3 years since they started. We at Things, we continue trying to follow more like the larger companies and what they need and how they should develop ways to work with smaller companies in a better way and so forth. And as one little service or activity on that kind of side of our house, we created eBazaar. In the middle of the Corona breakout, we said we have to find out a way to help our smaller companies to maintain contact to larger companies and also to find new companies to work with onwards, even though the larger companies typically have, closed the door and thrown away the keys. So this is our 6th eBazaar in 10 weeks. We have done one in Industry 4.0, smart utilities, artificial intelligence, smart buildings, smart mobility, and now smart factory. And our idea is to create a new national platform like we did with Ignite with this idea in the fall. So you can look forward for maybe 10, 12 eBazaars for the fall, much better planned, much more notice, bigger and better. But from a content point of view, it cannot be better than we have like today. So today we're going to talk smart factory. And the only type of members we invite to our eBazaars are members who are what I call corporate ready. We are not really into making sure people meet and create a POC together. I actually often talk about the death of POCs. I think it's the end of the road in many, many cases. We are trying to find ways to establish new business relationships between a large and a small company, which should be developed and scaled up over years of time. So for the only smaller companies we invite to present themselves in our bazaars. They are companies who we know are capable of doing that, both from product and from a company point of view and people point of view and all of that. So you have really, really top-notch, young, sharp, clever companies that you're going to meet today. So with all of that said, we have about 70 people signed up today. And I think we come from about 10 countries. Not only do we bring in customers, potential customers to meet those presenters, we also try to find partners, some media companies, some analysts, and some investors. When we already do this, we can leverage the event by itself to also introduce some of those people. So this is how it will work. I will moderate this. I will not do a lot. I will just ask the speakers to come in time and make sure they stick to time. And in the end of each presentation, I will try to manage a little bit of question and answer, depending on time. If you have a question, you put it in the chat channel, and I'll read from that. And then we go through all the 5 presentations. After that, we are done and over with, and you're free to go. And you will receive a post-event mail with some instructions. We ask you for all kind of feedbacks, because we need feedback to make this program much better in the fall. We record the event, so on our YouTube channel, you can go back to look at the event afterwards, also events you've missed. And there is a time note on each of the videos, so you can find specifically where a specific presentation is shown, so you can refer to it and bring your colleagues to take a look at it. And without any further ado, I think we should get going now. So I hope you sit comfortably and are ready to be really inspired and amused by those brilliant speakers we have with us today. So let me this. So do we have Niclas here? Niclas?
I am here, Magnus.
Excellent, Niclas from MTEK. So please share your screen and take it away.
Thank you, Magnus. Let me see.
There we go.
Okay.
Perfect.
Perfect.
Hear you.
Very good. I will just reset my timer. Okay. Hello, everyone. Thank you, Magnus, and the Things team for the opportunity to present MTEK during this fantastic concept. We've done it once before, and really happy to do it again. I'm Niclas Krantz, heading up sales at MTEK, and our vision is to make manufacturing simple. What if you could cut your yield loss by 50%, your lead times by 90%, and be able to personalize your product supply? What if you could automate the flow, allowing your staff to focus on better things and improve their work environment? What if you could get real-time visibility on the performance of your product supply? Well, with MTEK, you can. At MTEK, we change the world of manufacturing through digitalization and automation. We enable better products, production, and processes. And we enable our clients to be data-driven. But first, let's talk a bit about Smart Factory. What is it and what is driving it? So for starters, MTEK, we are in the smack middle of the Smart Factory. We're not talking so much about it, but this is really our core business. We are deploying digitalization and automation solutions to leading global companies at the moment. And we see and we know what is working and what is not, because we have experienced it ourselves. And who are we? We have been working in the manufacturing space for the last 20 years, focusing on how to make manufacturing simple. We have deep expertise in manufacturing processes, designed for excellence, and how to correlate data in processes, which is also what our 4 books on manufacturing excellence is all about. So back to the Smart Factory. One of the driving forces that we see is, of course, the maturity of industrial IoT, sensors, AI, analytics, what have you, finding its way down to the factory floor. We see the cloud players developing edge and hybrid services such as Greengrass or R, hoping to enter the most sacred of networks, the factory network. We see the telecom players building use cases for 5G on collaborative robotics in manufacturing, enabling this smart and connected factory. And what is the common denominator of these cases? Well, they're all technology driven. And don't get me wrong, at MTEK, we love technology. I mean, I don't know many other companies that have so many robots in our office to play with. We are all pretty geeky and we like technology. But for us, simple is smart. Smart factories need to be simple. And that is what we are striving for, starting with the complex challenges that our customers are facing today in the not so smart and not so simple factories. Let's look into that. Our customers are almost only from the manufacturing industry, but we have a prime focus on the electronics industry. What we see when talking to our customers is that the product life cycles are becoming shorter, and there's an increased demand on production flexibility. Manufacturers need to be more efficient in changing products faster, basically. We also see an increased mix in the production, meaning a greater demand on mastering digitalization and adaptive automation to remain competitive. The cost base of employees is increasing globally, and manufacturers, they have a challenge in both attracting and retaining operators. And finally, we see that manufacturers have a limited insight into their production, and they have a hard time understanding the efficiencies and faults that are happening there, which increase their production costs and impacts their quality negatively. So how do we in MTEK help them? mBrain is our factory intelligence system. With it, we can connect processes, machines, sensors, and systems together to create the brain of the factory of the future, or the smart factory, if you like. Looking into more details, mBrain can simply be connected to any machine in the manufacturing flow. With it, we can extract process and machine data for reporting and doing drag and drop analytics to it. We can also write down to any machine, which we are allowed to write to, basically, taking corrective actions based on the insights that we see in our system. As everyone else, we have predefined KPI and performance dashboards and reports. And for us, it's very simple to allow you to define your own reports. You can use it for analytics, SPC, or defining your own custom ML algorithms on any given process parameter from your production. And again, this is simple. Defining your ML model, it will go faster than making a cup of coffee. With mBrain, you build a digital representation of your production flow. Some like to call this a digital twin. For us, it's just a simple way to make sure that your process is running as it should. In the flow, you can drag and drop points of analytics and use various quality tools to keep on improving the production. And yes, it's also a MES system with order management, production planning, and inventory. It is pretty simple to build custom integrations to existing systems or just use mBrain as a standalone product. So if mBrain is the brain, our mCell would be the hand. mCell is a software-defined flexible automation solution, which can be seen as a digital building block of the simple factory. Looking into more details, what we've done with the mCell is really to simplify the hard work that goes into robotic automation. When you're doing an mCell project with us, it's very unlike a normal robot integration project. And why is that? Well, first of all, our automation solutions are all software defined. This means that we use our software to create reusable and adaptive use cases. The cell will not be programmed by a robot programmer from MTEK or from anywhere else, but rather from existing data sources, such as CAD or Gerber data, making the application simple for the factory team to manage and change when the production is changing. Remember what I said about shorter production cycles earlier on? That's why. We have built the mCell in a very modular way with simple hardware setup and standardized components. This means that fixtures, feeders, and fingers can be ordered from your local CNC shop. But simple things can sometimes be too simple. But we have spent the last 3 years perfecting simplicity to also make it flexible. This means that we can make the initial deployment of an mCell in just a few weeks. We can develop new use cases in just a few hours. And we have a changeover time in just minutes. We're even deploying our first remote mCell right now in these Corona times. In May, we launched the first industrial use case for this, which is odd shape placement for electronics as a first digital building block of the factory of the future. And we are adding new use cases as we grow. To show you what this really means and how it fits together, in this video, we're going to see how our software-defined logic and the use of, I don't know if you hear the sound, I do, and the use of Gerber data is creating a custom pick and place application for through-hole assembly. Try go make yourself a cup of coffee and we'll see if you're faster than our application. So first you move the feeders to the position where they are. You take the components, drag and drop them. You select the components or the positions where you'd like the components to be placed. You select what arm should start first. You create a recipe. And once the recipe is created, you can choose basically any robot that you would like to push this recipe to. Done. So connect if you want to change your manufacturing through digitalization and automation. Connect if you want to have better products, production, and processes. Connect with us if you want to be data-driven. I'm Niclas Krantz, heading up sales at MTEK. Ready for some Q&A, Magnus? I'll stop sharing also. Right now, I don't hear anything. You're muted, Magnus.
Sorry. Yes. Sorry. We don't have any questions yet, so I'll tell you. I'll ask you one. How many people are you at MTEK? What kind of state is the company in and so forth?
Yeah, so we're around 30 people right now. This fall, we received first financing from external investors, and we are raising more capital as we grow. Have quite, let's put it this way, aggressive growth plans in the coming year.
Good. Let's see if we have any questions. No other questions. Let me see. Which role plays 5G and edge computing for MTEK services?
Well, 5G, let's start with 5G. 5G means so much for many different people. I have a background from Ericsson, so 5G means a lot to me as well. With 5G, I think, the private networks that could be created could be used for our services. However, looking at robotic solutions, they still need power, they still need vacuum air, and so on. So the connectivity and the 5G latency that it gives is not so critical to us right now. We see some use cases, but not so much right now.
Great. I have another question here. I want to know if this is programming by demonstration. Pretty sophisticated stuff.
If this is programming by demonstration, I'm not sure what programming by demonstration means.
I think do the following, Niclas. Tell again the example of, for instance, programming from CAD.
Yeah. Okay. So this was from Matt. Hi, Matt. How are you? Good to see you again. No, so what we do is that we really create reusable and readaptable solutions. So for the through-hole assembly, for example, we have spent a long time to building a method for that. So in our software, you basically upload your CAD data, the Gerber data, and then you drag and drop basically the components that should be placed into specific positions. So instead of really programming it, you just drag and drop it. And it's not by demonstration if that is like moving the arm, picking and placing, because that doesn't really work in the kind of tight environments that we are in. You have a big kind of complexity and variation in the process with conveyors, components that are not always specific. You want to be able to actually remove the robot and plug it in again. So it's not by demonstration like that. We can take a call later on that. I'll explain it more.
Great. I think we stopped there, Niclas. Thank you so much. And please don't forget to share your screen. And I'll see if we have Martin there, Martin Rugfelt. Are you around?
Yes, I am.
Of course. Welcome, Martin. Please share your screen and put on your video and all of that while I tell people that we are not tied to any kind of city or anything. We work at least nationally. And I'm glad to tell you that our first speaker's company is based far up north of Stockholm. This one is from Malmö. So
and the one from Malmö can't turn his video on.
is that right?
It's blocked by the host.
Oh,
now.
Linda, can you please
it's fixed.
look at
Thank
that?
you.
Perfect. Nice. And do you share your screen?
Give me 1 second, please.
Yeah. No worries. Here we go. And then go in presentation mode and we're happy. There you go. Loading. Perfect. Take it away, Martin.
All right. So, hi everybody. My name is Martin Rugfelt. I'm the CEO and founder of Sentian.ai. We help large industrial companies transform themselves through AI. So for you who don't know us, we're a deep tech company. We're focused a lot on reinforcement learning and optimization. We focus solely on industrial AI applications. We have a very strong R&D team and an ambitious roadmap. We've so far managed to do quite a few technical breakthroughs. I'll tell you a little bit about the effects of those in the presentation. Founded in 2016 by a few guys that came from another AI company that we exited to eBay. We're now 20 AI experts and we're growing. Some different partners and been finalists in Nordic Startup Awards as Best AI Company for 2 years in a row. And we have absolutely great customers too. So, and we have three products. So we have our predictive maintenance and anomaly detection product, where we do that for larger implementations, really. And we have Icon, our intelligent control and optimization solution, which I'll tell you a little bit more about. And we have our intelligent optimization, so pure optimization, which we apply to logistics and supply chain and that kind of stuff. But I'll stick to Icon today and talk about AI as a decision maker. But before that, let me take a step back and just get some perspective on things. Things are happening really fast in the society. But if we try to measure it, we can go back to between 1900 and 2000, so 100 years of progress. And we look at what happened in that time, and there's a lot of things that happened. But things go faster, and how much faster? Well, according to Ray Kurzweil, we managed to squeeze in another 100 years of progress between 2000 and 2014 on the same scale. And now we're heading for another 100 years of development in just 7 years. So one needs to ask oneself, where will you be in 7 years if this is the speed at which things are happening? So everything from R&D to operations to after sales and all other parts of businesses are affected by AI. And there's a lot of things going on in that space. And if you look at a company like China, for instance, which is not only challenging European and US incumbents in all markets when it comes to normal industrial stuff, they're also the leading company in new AI patents. So it's quite interesting to see how quickly things are moving and what will happen in 7 years. And this, by the way, will probably be even accelerating even further by then. So where will you be in 7 years is a fairly relevant question. So taking that perspective and looking at Industry 4.0 and the smart factory, I think it's really a lot about speed and efficiency. So we're really talking about how we can increase speed and efficiency through digitalization, obviously, but also about AI technology and how that is applied to the smart factory. And speed and efficiency, how does that compare to people and industrial systems? Well, it doesn't always equate. And it's really about that we people, we are limited in our capacity. We can only do so much that as people are limited by being the human beings we are in our brains. And industrial systems, on the other hand, they have its capacity today. And Usually one tries to run these systems in a robust state of production, so it doesn't go down, but that may very well be below what the actual capability is if we had a control system and industrial system that was more efficient. So we should be able to do things better if we had a more dynamic system. So if we look at what the challenges of industrial systems are today, so they're high dimensional, nonlinear, and stochastic in their nature. And classic industrial systems, are linear and non-adaptive in general. And they're also very reactive instead of proactive. So they don't have the predictions, they don't have the vision of the future. Not strange, been based on the things that was developed 50, 60 years ago, and current systems have not evolved that much. Standard protocols are passive, and we focus a lot on performance and sacrificing performance for robustness and avoiding these interruptions. So data is dirty and so on. So lots of challenges. What we really want to have is systems that are faster, more dynamic, much more proactive, so predictive in their nature, and can deal with the non-linearities, and obviously more accurate while still staying very robust. So we believe that you really need a new form of AI to deal with these things. So the next step in deep learning effectively with model-based reinforcement learning, and that's also what we've built. So our solution really integrates on top of the automation stack. We can also connect to digital twins. And what you do, you really boost your own control system with AI, and you add the intelligence to this automation system for bringing higher yield and better quality. And as I mentioned, this is based on our model-based reinforcement learning platform. So what can you expect from this? Well, there are a range of things that we are looking to solve. We want to improve yield and productivity, quality, reduce waste. There's also the human side of things. We want to reduce human errors and deal with the fact that there's a lot of experts being retired, and there's not enough experts in these operations. And there's also other opportunities with this, new and added revenues, easier installation, customization, continuous development of these systems, flexibility, autonomous systems. So lots of opportunities and benefits. So I wanted to just quickly touch upon a case that we've been doing with another customer, Imagimob. It's a highly automated, high-tech manufacturing company, which had their goals of both reducing cost and improving revenues. And what they had a small but significant process variation in their operations, and they wanted to improve their accuracy of the products they were building and the yield. But the challenge from a data perspective was that they didn't have much data. And then they had a variation that drifted over time, and there's complexity around it. There was lags, time lags, and so on. So lots of complications. But after installing our Icon software and customize it for them, we got to a very good deployment. We increased the quality with 20%. We're now handling these updates automatically and running the system automatically. And we've applied it to a range of other sensors. So it's really about enterprise AI at scale. And however, these kind of problems that you see is not obviously unique to this kind of manufacturing case, but really to a range of other areas where you can improve these systems for increasing the speed and improving the adaptivity to the system and so on. So how difficult is it to do these kind of things? Well, the core need is obviously that you have some data. But as mentioned before, we can even deal with situations where there's little data, as in the Imagimob case. Not that we can't handle big data, but data is often an issue. So we have a very, very efficient, sample-efficient system for that. So a typical project from this ranges from a few weeks to a few months. So it's not a massive impact in terms of project time. However, the impact in terms of business can be very, very big. As in the case of Imagimob, we did 20% improvement in quality. That's a very, very big step. So my question to you is obviously, have you got a challenge that you would like to see if we can help you with? Well, in that case, let's meet. So my contact details are here, and be very happy to connect with you and demonstrate the solution or discuss any challenges you may have. Yeah.
Excellent. Thank you, Martin. Good as always. So let's see, I have a question for you, which is, I'm not sure about how well you are into those specific markets, but the question is, where do you, I think it was a response to your question about where are you in 7 years? Where do you think you are in preventive healthcare and AI telling you how well you are in 7 years?
Well, actually, I'm on the board of a predictive healthcare company, so I think I can potentially answer that. It's a tricky one because data from people is very difficult to capture. You have to have good data sources that comes on a continuous basis. We have a solution for predicting health issues for dialysis patients, and the benefit of dialysis is that you get it on a weekly basis. You have to come in and have your dialysis. So data is the big challenge in the healthcare industry. And if you have data, you can do these things already. It's slightly different type of data, and it's definitely a different type of situation to the industrial case.
Great. I see if there's no more. Yeah, here's a question. I could see that you worked with some railway industry companies like DB. Could you please elaborate about your work with them?
Right. So we are working on a few projects there, both in predictive maintenance for the actual rail infrastructure, and we're also working with optimization. So it's in another part of our business. We have a very strong hand in optimization software, where we do we have our solver for nonlinear optimization, and we apply that to staffing problems as well as some issues around maintenance planning.
Great. Thank you. And then we have another question here. How did you go from no data to full data in Imagimob case?
We didn't have no data, we had little data. And we still have not a huge amount of data. So if I expressed myself in a case so that it sounded like we got full data, that's not really what I meant to say. We have been able to do a version of this that is very, very sample efficient, and that resulted in a well, we've spent quite a lot of time on building in capabilities around this sample efficiency, and we managed to get to that state where we can use the very little data to still get a very good result for them.
Excellent. So let's say I don't have any more questions. Can you just tell us very briefly about your company status, where you are and how big you are?
So as mentioned, we're about 20 people. We're self-funded, growing mainly in Europe today, having global ambitions. We've been very focused on building our product portfolio. So we have both our record-breaking optimization solver for nonlinear optimization, as well as our predictive maintenance platform and the platform I've just talked about. So our model-based reinforcement learning-based solution for boosting control systems and automation solutions.
Brilliant. I think we stop there, Martin. Thank you so much. And please don't forget to share the screen while I'm asking if Melissa is around.
I absolutely am.
Great. Welcome. Welcome.
Thank you.
So have you forgotten the slides today again, or?
I did. I actually, when I started in my previous role, I upset my whole team by saying I didn't like slides, which caused everyone a huge problem. So I must admit that this is a personal fault, and I need to work on rectifying it. Me and PowerPoint aren't very good friends. So what I get to do instead is I get to talk to you guys. And I have this wonderful system that involves a green sheet of paper and a yellow sheet of paper and whole piles of little stickers stuck all over it to remind me what I need to say in the right order, which sort of works like slides, but it's kind of like secret messages to myself. So I think the first thing we need to do is talk a little bit about Ekkono and who we are and what we do and why we're there. And I think that will help set the scene as to what we can do around the smart manufacturing space, because we're a little bit different from the first two companies that have been presenting, and that we make a component that goes into other people's products. So we do machine learning, artificial intelligence software that you can build into your existing products. See, this isn't a cloud solution. This isn't something that needs to have anything more than blue sky thinking. You, as an engineer, have this real challenge. You've got software. We actually just heard it now, that the control loops and the processing, all that, it's difficult if you're doing it with linear systems. But actually with machine learning technologies, you can get all sorts of benefit from that. But it's kind of difficult. How do you take that leap from having lots of data to making something that actually can control machinery? How can it manage it and monitor it and deal with all of that? And that's sort of where our library fits in. And it's super simple. It's so simple that we can actually get you set up on a demonstration environment, and you can do some challenges. And they actually set this to me, and it's been 20 years since I wrote code professionally, and I even had to figure out how to do Python. And even I managed to figure out how to monitor what our toy train was doing and when it was going to go next, and predict that with pretty good accuracy. So, you know, it's actually a really cool little tool. It doesn't need any new hardware. So we're not expecting you to buy boxes with GPUs. We're not expecting you to install rack servers to go with your equipment. We're not actually even slightly the right people to talk to if you need to do whole factory improvements. But if what you have is a component, if you're producing something that goes in that factory, in any factory, anywhere in the world. So for example, maybe you make a heat exchanger and you need to make sure that it's being serviced optimally. How do you do that when it's being installed anywhere, in any environment, in any industry? You know, you need to have something which can help you improve your efficiency, that will work on that machine, that will work on that deployment, regardless of where that deployment is. You know, your same physical hardware could work across any number of verticals. One day it might be installed in a dairy, and the next day it might be installed on a factory where it's processing pure water. And the maintenance profile between those two scenarios is totally different. And it's really important that you learn how they work and you understand what needs to be done in order to make sure you're providing that optimal service benefit to your customers. And you want to be able to do that, you know, as a manufacturer of this equipment, you want to be able to do that without having to rely on a lot of infrastructure on the site. There's something fundamental about having it built into your product where it will always work, where it can be deployed anywhere in the world, regardless of how good the connectivity is, or even if it has connectivity. And know that it will learn its local environment. It will do that incrementally, which means it gets better with experience. It means that the data doesn't need to leave that machine. So you can actually have production lines, whole production lines, where everything about that production line, the optimization, is staying on site. So you're not sending your customer's production information up into your cloud service. You're keeping it all there, which we've already heard from previous people, and I'm sure we're going to hear more about now. Making sure that it is always available to you and it's always being worked on. But you can take the inference that you've built from learning from that, and you can then analyze that, which gives you some really interesting side effects. No, maybe that's not the right term. Benefits that you can take to compare performance across different types of devices in different environments without leaking any of that information. The other big advantage of this is that it runs on any device, you know, little memory, lots of memory. Few sensors, many sensors. So let's say you're processing megabytes of sensors a second. You know, you might have reads coming off 10, 20,000 times a second for these pieces of equipment. How do you process that if you have to transfer it somewhere? We don't. We can take that, but integrate it into your existing software, and we can do all of the inference, the analysis, the interpretation from that really quickly. Faster than any of the open source libraries that provide machine learning on the device, much faster, which means more efficiently, less power, And we can use that to predict when something's going to happen. You know, are you going to run out? Is your component going to wear out? How will you know when that is, when actually every single device is behaving differently? We can use it to identify drift. So if a tolerance is getting out of alignment in the machine, we can actually see that happening. But we can see it on a particular run. So you could actually program your machine to say, this is the start of a production run. You do your first couple of productions and you say, yep, this is working right. Great, we're happy with that. And then you can use that knowledge that you've just learned from those initial runs to make sure that everything that happens on the rest of that run is performing correctly. And you can do a hybrid where you take that plus your generic model, which should work for every machine you have, and make sure that what you get at the end is correct for this run and correct for your machine, which will allow you to identify all sorts of really interesting relationships and give your customers a highly personalized experience, which adapts, adjusts, and it conforms to what they need to achieve, but it still lets you maintain some level of control and consistency. And we do all of that and combine it with the ability to predict the confidence level. So we can say this prediction, we are this confident on, we know this is right, or actually we're not so sure about this. It's, you know, we don't have enough information to be able to give you a 95% confidence. So we're only going to say this is a 65% prediction, which allows you to make decisions in your control logic about whether you need to take action, collect more information, or actually if you should flag this to somebody else because they need to look at it and confirm everything is correctly configured. So it's, you know, a huge variety of things that you can do with machine learning. And the thing I love most about it is that it applies across all of these different industries. I'm one of these horizontal people who thinks verticals are great for a way of describing what markets you're going into, but actually true technology that can go across and work in any different supply chain and any different type of solution is really where the big changes come. And if you get software into your development team and into your products, that gives you flexibility regardless of what kind of product you're making. And that could work in any vertical you need to address with minor changes and without you needing to have full data sets of absolutely everything you're ever going to encounter in the real world, which is a vanishingly difficult problem. So, you know, we're here to help. We provide library and software technology, it's tooling. We're not a consultancy service, though we're very happy to help you figure out the best way to get started into your industry and help identify where is a good entry point. And we've done that successfully with 20 customers so far, which is really awesome. And that's a huge range of industries. And the thing they all have in common so far is they're all gaining big efficiency benefits. And I think that's really awesome. You know, we don't talk enough about the environmental and the green benefits, but you know, we did a little audit of that not so long ago, and it was fascinating how many of our customers gain big efficiency benefits. And those efficiency benefits, by coincidence or by design, depending on the industry, result in big CO2 reductions. And you know, these are just the little things, and just changing little bits in every one of the items that goes into these factories will make a step change. And it gives you a lot of extra flexibility. So I don't really have a whole lot more to offer today. I thought I could possibly sell change detection, but we've been there. And I would like to say that our offer on virtual sensors is 2 for the price of 1 is still there. And if you don't know what a virtual sensor is, that would be a fantastic question to ask me, because they're really, really cool and actually really useful for manufacturing. I couldn't describe what they were last time. I hadn't actually quite got my head around it, but we're there now. So it's all good. And I think with that, I guess we'll ask if anyone has any questions.
Wonderful. Thank you so much, Melissa. I think there's a question. What is a virtual sensor?
Oh, fantastic. What a great question. So a virtual sensor is when you train a model on all of the different inputs, including inputs which are hard to collect in the real world. So let's say that you are, I don't know, producing a gas turbine. And to measure the NOx emissions requires a very expensive sensor. You know, it's not something that you actually want to build into the turbine because it's just frankly too expensive. So what you do is you train a machine learning model on all of the other parameters, the operating efficiency, output gas temperatures, etc., whatever is required. And it will learn what the NOx emissions will be based on that. And then you can produce a sensor that comes from just reading your normal sensor data. So you put it into the model and it will give you a number which reflects what it would be based on what you trained it on, which, you know, that's a simple example, but you could use it for all sorts of things which are difficult to measure or perhaps are more useful for an end user to see rather than a whole lot of scientific high-speed parameters. You could slow it right down and give them something that a user can see that's actually useful. You know, maybe you want to describe wobble, but actually you don't measure wobble. You measure all sorts of other characteristics about your process. So it's actually a really very simple in one way, but actually extremely powerful technique, and a great way to add functionality to something you've already deployed without needing to do anything physical. You know, it's a software change.
Excellent. Now, I obviously knew what a virtual sensor is, so I just had to read. Oh, that's fine. I have another question for you. Could you please share your experience working with big corporates like Volvo and ABB, and what are the lessons learned?
Yeah, absolutely. I think
you don't have 2 hours. You have to do it in a couple of minutes. Okay,
no, that's fine. And actually, that's probably a really good answer. You don't have 2 hours. You know, every experience with a big corporate can be an interesting one. I think, like everything, you have to find people who really gain benefit and value. And when you can demonstrate that, it works really well. You know, we have really great partnerships with all of our initial customers, and we are working quite well together as far as getting feedback. What do we need to do? How do we make that work? And I think with anything, it's very easy to get lost in a big corporate. So you need to make sure you're talking to the right people, and you need to make sure that they're actually hearing what you're saying and you're hearing what they're saying. Because if you get a mismatch, if you're not listening right, you will never find out whether you've got the right engagement. And once you get the right engagement, it can go really quick and then stop, and then really quick and stop, and really quick and stop. That's fine. It's a good way to get lots of cool stuff, but you just have to be in the right frame.
So can you tell us very briefly about the company and the state of the company and so forth? You're from the West Coast, just to mention that. So not you personally, but the company.
Yeah. Yes, no, Ekkono is from the West Coast. We are, you know, pretty reasonable size, about the same as everyone else, 23 people. We've had a few rounds of funding, and we've conducted 20 paid proof of concepts, and we have signed customer agreements. We've actually signed a really interesting agreement in Japan the last week with a customer that we've never met in person, which is a sign of the times, I think. And we've supplied software to companies running the whole range of Internet of Things solutions, all sorts of different industries and different requirements. And we have a fantastic, deep technical team, you know, people who really love mathematics and that, and we have a very strong research background to come from it. So we don't have that industry experience, but what we have is the technology experience, which works really well with companies that have great industry experience.
Great. There's time for another question. What's your business model?
We sell a license to a library, and it's a per unit deployment cost, and then a support fee for updates and maintenance of that. So it's basically a cost per unit that you would pay as part of the deployment process. We try and make sure that the license is right for the type of deployment, because IoT, some companies have tens of thousands of devices and some companies have tens of devices. So it's quite hard to say it's this number, but that is the basic principle. Yeah.
Great. I don't think we have any more questions at the moment, and well, it's good time to round off there. Thank you so much, Melissa. And
thank you very much for having me.
You don't have to unshare your screen, because you don't do it.
Okay, I won't unshare my screen. How about I just stop my video and go on mute?
That's perfect. That's perfect.
Perfect. So thank you very much, everyone.
Yeah, welcome. Thank you. So do we have Rajet there?
Yes, of course.
Of course.
Can you hear me?
Yeah.
Can you see me there?
Turn on, share your screen, and you know, Rajet is also from the West Coast. It's quite an interesting mix today we have. It's only one company based in Stockholm, actually.
And one based in Malmo, I believe, as well. Martin is in Malmo, right?
Yeah. So take it away, Rajet.
Yeah, I hope everybody can see my screen. Magnus just confirmed with me.
Yeah.
All right, so my name is Rajet, and I'm the co-founder and CTO of Viking Analytics. And at the next few slides, what I'm going to talk to you about are some of the challenges that heavy industrial companies have experienced in terms of building and scaling reliable smart manufacturing applications, be it predictive maintenance or anomaly detection or process control or automation. And I'm going to speak about 3 use cases where we have worked with partners in the industry, customers in the industry, and shown tremendous benefits and potential. So this is what my talk is going to be. And briefly about ourselves, Viking Analytics, we were founded in 2017, and we are headquartered here in Gothenburg. We also have a satellite office in the Netherlands, and hopefully this year we are going to open up in Germany and in China as well. We cater to multitude of industries. I'm going to speak about a few cases from different industries. 15 employees, 6 of them having a PhD, so quite heavy on the R&D side of things, and a very strong, experienced development team as well. And we closed our seed round last year, and given our current situation where we are seeing a strong product market fit, and we are scaling, we are looking at raising our Series A, quite generous, elaborate Series A soon. So that's about ourselves. And since I'm going to talk about smart manufacturing applications, let me throw in a fact right there itself. Building smart manufacturing applications is a non-trivial aspect, especially when, as Magnus has been speaking about, especially if the target is not a POC, but if you're thinking about building a reliable and a scalable one that you want to build at enterprise level. And there are a myriad, 100 reasons as to why that's the case. And I'm going to talk to you about 2 specific challenges that I'm specifically focused on because that's what we specialize in as a company. I'm specifically talking about the daunting challenges that companies have in terms of data quality, in terms of capturing expert knowledge at scale, and getting to insights, actionable insights. So this is the first challenge I want to talk to you about, because we see today that many of the companies who are embarking on the smart manufacturing journey, they are data rich, but they are information poor. And what is the reason for being information poor? Because many organizations have to depend on their experts to import data, combine multiple databases, and clean them and prepare them, and then analyze them to get to their actionable insights. And a lot of the tools that they use today are based on manual analysis using spreadsheet technology or Excel files. And this is not a very scalable way of doing, given that you don't have too many experts, but you have thousands of machines and millions of sensors. So this challenge number 1 that I'm going to talk to you about. The second challenge I'm going to talk to you about is once experts get to insights, there are huge challenges in scaling an insight from a POC into an industrial AI solution that meets KPIs required. And this is the other challenge we are seeing across the board. And these are the 2 challenges that I'm going to talk to you about, because what we do is primarily enable heavy industrial companies who start with their raw sensor data or raw data in general. We enable them to convert this raw data into useful information, where we have experts analyzing data at scale and adding their knowledge to the data at scale and getting to actionable insights and operationalizing insights at scale at enterprise level. And this is where our product suite comes into picture. Specifically, I'm going to spend 1 slide on our product suite. It's a software tool to begin with. It's a software called Multivis, and specifically to begin with for dealing with data quality and enabling domain experts to handle high dimensional data without needing advanced data analytics skills. We have a tool called Multivis Explorer, which is a self-service tool which enables subject matter experts without data engineering skills or advanced analytics skills to be able to import data, clean data, prepare it, analyze it, annotate it at scale, and get to their insights. We also enable them to perform really complex engineering tasks and analytics functions without needing advanced skills at all, which includes anomaly detection, change point detection, root cause analysis, mode identification, and so on and so forth. That's on the analysis side. Once they get to this analysis, once they get to their insights, it's about scaling the insight in from a POC to an app or an industrial application. And that's where our AI deployment in a box solution plays in, where we enable efficient training of algorithms and building models with domain knowledge, rapid prototyping, and efficient deployment, testing, and scaling. And in the next few slides, I'm going to really talk to you about 3 use cases and what were our main learnings there. So the first use case I want to talk to you about is about one of the largest German manufacturing companies, which wanted to implement a predictive maintenance solution based on millions of sensors that they are deploying out in the fields on different machines in thousands of plants. And one of the challenges that we are primarily helping them with our software, with the Explorer software and the integrated software, is how to that many predictive maintenance solutions or reliable anomaly detection solutions require expert annotated data, because you want to have false alarm KPIs which are good enough for the organization, which are profitable for the organization. And the challenge here is that scaling expert annotations for the large volumes of data that they're collecting is really a big challenge. It's done manually today, and that's a really big challenge. So how did we really help? Our solution, our Explorer tool, helped to automatically find interesting regions, automatically identify operating modes, failure modes, and this becomes the foundation for experts to start annotating the identified modes. And these annotations would be then scaled by our software to all the other huge swaths of unlabeled data that they have collected, which means that they have to just perform annotations on a small data set. And based on that, we, along with the customer, develop features which help them handle minor stoppages, major stoppages, machine health predictors, and more. So what are the gains? Well, the reality is that it's under deployment as of now. The solution is being deployed probably in a few tens of plants this year and a few hundreds of them next year. And we are looking at huge euro savings already. And the main learnings I really want to show here, and that's really what I want to share here, is like false alarms are a big deal breaker. And if you want to handle false alarms, you need high quality training data in some scenarios. But training data is scarce, and it's a very expensive resource in this industry that we deal with. Another learning that we've seen here is that both anomaly detection and root cause analysis and predictions are becoming very critical in the area of proactive maintenance. And in the area of industrial AI, it's not just about algorithms, it's also about software engineering and AI DevOps, which are really becoming the bottleneck for many of the companies getting into the space. And that's something that this is a story we see across the board, across all industries, across different use cases we're dealing with. And that gets me to the next use case, energy optimization for a leading chemical company that's trying to optimize energy and production, and which would be done manually before our software came into picture. And after our software came into picture, the software would be able to identify operating modes, identify abnormalities in different of energy consumption, different operating modes, and then we would optimize production and energy consumption based on our optimization tools. And last year, after deployment, we already saw a 6-figure in euro gain 2019. So a big learning that we had here was that because there's an ambition to build not just this application, but a whole bunch of applications across the organization, across multiple plants, we realized that having a unified methodology framework for building and scaling AI applications could result in huge cost savings across the industry. And of course, the same things as before, data quality is a deal breaker, but a naive observation has been that simple algorithms can help a long way when you do many of these stuffs. And finally, let me wrap it up with this example here, where we are helping a leading pouring company which pours molten metal in foundries to automate their pouring process. Today, it would be manually controlled, and And now with our solution, they have been able to automate it completely. It's in deployment in 3 foundries already, and they're already saving close to €1 per pour. That's quite major. And it's going to be deployed in about 10 to 15 foundries this year, and maybe another few tens next year as well. One major learning here has been, of course, the combination of data, real data, and data from sample simulations and digital twins. Once again, the simplicity of algorithms definitely went a long way. And with that, I would like to stop, because now I'm talking about customers, 12 customers, really growing, as I said before, in different segments. And if you're interested to know more, please reach out to me. There you are, store shop 10 minutes.
Perfect.
Thank you.
Thank you, Rajet. Let's see if you have any questions from the audience.
Yep.
And now you served me with all data before, so I can't ask you about that while we're waiting. So let's see. No, I don't think we have any questions from the audience. It's great. So you're expanding already, not only with customers, you also have people in other offices and stuff. Is that how you expand?
Yeah, exactly. So to be honest with you, this slide is at least 2 days old. We just signed a contract. We just signed a contract today. That's my 13th customer, and probably signing our 14th customer next week. So it's unbelievable what's happening, because probably by the end of the year, we are looking north of 20 customers and maybe about 20 resources. But that's the idea, is to really raise the next round, and also set up new sales offices in China, Germany, and the US, even for that matter, where we are seeing a lot of traction. So it's an exciting time for us.
It is interesting. So I hope people realize that I think I haven't mentioned the word startup yet, and I think nobody else has done that. So we are not really working with what I call them corporate ready young companies, or focused companies, or innovation companies. There's not a good name for it, but all companies you listen to today are in that role. And it's amazing to me to see how you all the 5 we meet today, they are actually expanding quite nicely internationally, despite Corona, despite everything else. And because I think a lot of people have difficulty reaching out to customers in general these days. So do you have reflected on that? How come that you actually can, or capable of expanding here and now in the middle of those crisis days and so forth?
As we've seen with any crisis, right? I mean, crisis are in one sense is a cleanser. So things that are not going to, are not meant for the future, they have to be transformed and be made ready for the future. And digital transformation is a recipe that everybody are talking about. Martin touched upon it by providing a timeline as well. And that's why this rush, we're getting to see the rush from the governments, from organizations, from people. People are thinking about what next. So, and that's really pushing the next wave. So it's been positive, and as you said, it's really phenomenal that more than 5 startups are not startups anymore, because their business models have become more mature.
I have a question for you here now before we start. It's interesting that you took advantage of simulation data sets as well. What kind of simulations did you perform?
Well, it depends on the scenario, right? So we looked at a situation where we wanted to simulate, to speak about a PLC system, a control system. And of course, we had a lot of data from the control system itself, but we also have a lot of simulation data which reflects the true behavior of a PLC, which is a well-defined theoretical entity. And combining simulation data with with real data, resulting in hybrid data models, has been one of the trends we are seeing everywhere. Right now, we are working with a forging company, and it's exactly the same trend there too. A lot of theoretical knowledge in terms of digital twins and simulation data that is combined with real data to build hybrid data-driven models. Something that I'm seeing across the spectrum, if that makes sense.
Excellent. We have to stop there, Rajet. Thank you so much.
Guys, really nice talking to you.
Great. And let me see, is Åke there somewhere?
Åke's here.
Yeah, Åke's here, that's great. And can you share your screen and turn on your video? And
yes.
There you are, great. I see you at least. Here we go. Yes. Perfect.
Okay.
Great. Take it away, Åke.
Yeah. Being the last one out, it's always challenging, but we will do our best. Talk a bit about Edge AI, and Melissa touched upon the subject. It is about having AI algorithm out in the hardware and not being computed in the cloud. Imagimob has a software tool for this, and I will describe a bit about that. We are specialized in AI, and we have an idea or a vision that anyone that would like to build an AI on the edge model should be able to do that with a tool, with a proper tool. And you don't have to be a die-hard AI expert to do that. You could be a domain expert or pretty good, but you don't have to be a PhD in data science in order to do that. So that's the vision, and by that we have developed a tool or a tool set, which we rent to our customers. It's based on providing AI models on very small sensors with small footprints. So it's for low-cost sensors and not maybe for the biggest sensor and the most expensive sensor. We have been in business since 2013. We are based in Stockholm, and we have about 15 employees in the company. We have run more than 20 projects over the past years, and some learnings from these projects are that a lot of time is about data. It's all about data, of course, but to really preparing the data, collecting the data, identifying, do it again, profiling, sourcing, cleaning, etc. And without having a proper process and the proper tool sets for this, it is a struggle. And we have also found that someone else discussed the same thing, that our customers, mainly the big corporations of Sweden and internationally, they want to build their own AI skills inside the company and not being too dependent on suppliers. And of course, if it's all about data, who is owning the data, of course, it's the customer themselves who owns the data. And we have seen that there are a few tools and processes and technology that supports the whole role in an AI project. And therefore, our tool, Imagimob AI, has been developed. And it's a tools as a service. It's a subscription-based service. You pay by the month or by the quarter. It's an end-to-end service from data collection to a deployed AI model. It supports deep neural network, deep learning, with a lot of the methods, the normal ones. We are focusing mainly on time series data coming out of a number of sensors like accelerometers and radars and so on. And the result of an AI model deployed with our tools is with constraints of processing power. We can put in an AI model on an ARM Cortex M0 with 10 kilobytes of RAM. Maybe that's in the lower area, but we don't need so much computing power and hardware out there in order to deploy our AI model. And that's where the strength and maybe the uniqueness of our tools come out. It is AI on the edge for very, very small sensors. Going further, what about smart factory then? How could we support here? And I say, like Melissa said, we are not developing or deploying a system. It is a component which very well could fit into any infrastructure or system that is also a smart factory. We could, you could start using our tool in a retrofit case where you have existing sensor, but maybe you have some more capacity on this sensor to put in an edge AI model. Low-cost sensors, small footprint for the AI model. You can start right away because the tools are there. It's ready to use, and you can connect it tomorrow if you like. And we also believe that this tool could help out in empowering a lot of roles in a typical AI transformation project. Everything from collecting data to domain expertise in the field of, in this case, production, but also for data scientists and also for hardware and firmware engineers. And of course, the use cases, many of you before me have discussed about use cases in industry, and it's the same here. It's for improved yield, improved productivity, predictive maintenance. But the use cases could be, for example, for motions, for vibrations, noise, pattern recognition, and things like that. And how is it working then, the tool? It's a modular tool set where you start with the data collection, and the data collected will be synchronized with metadata, for example, a video stream. You can label it in the field, and you can, if you have an internet connection, upload it data into the cloud right away when you collect the data. The next part, which we call the sampling, that you can access all the data you have in one place. You can visualize the data, you can manage different sets of data, you can label sets of data, and you can also let the AI model label the rest of the data in order to automate the whole thing a bit more. The third part, which is probably the most exciting, at least I think so, it's the generation and the training of the AI models. It will be done automatically. And you can verify and compare the performance of all your AI models in terms of, for example, what are the level of accuracy you want to reach in this model, etc., etc. And that's of course, for trained data, not for untrained data. But with this, you can find the best AI model when you have crunched everything. And in our service, we have a GPR cluster you can connect to. And if a customer wants to build their own cluster, that's of course possible. But if you want to start right now, it's better to use our cluster. The model verification comes then. And here you convert the AI model into code. And the code is optimized for different CPUs. I mentioned ARM Cortex, and if you use an ARM Cortex architecture, you can of course use a lot of silicon on that, but it is an optimized for the different target devices, and it depends on RAM requirements, the floating point units, etc., etc. And here is probably the heart of all our products, so to say. The last part is the more of you can loop it back and do more data collection. You can go back and build more models, etc., etc. So we believe that there are benefits of using our tools in this field of smart factories. Also, you can do an end-to-end service. You can use it for several roles in a digital AI transformation. It's a way to democratize the whole use, because you don't have to be a true expert in the field of AI in order to use the tool and to build AI models. And it gives you a very, very good understanding of how well the AI model works. And the most important thing we feel, at least, is that the customer is taking control of what is theirs, the data and the process, and they do it from start and just using a tool for this. We can shorten the deployment time to ready to go AI model. A year ago, it took us 12 weeks, and we can do the same actions right now in 1 week using the tool for using everything in the tool. So if you as audience here want to deploy something and not using deploy AI and not using expensive sensor, instead reusing infrastructure you already have, and have some more extra RAM on your CPU, it could be very well spent time to see if our tool could help out to deploy an IA model for your existing sensor. That would be a low-cost AI transformation for you. So finally then, check out our demo video if you like. It's on our home page, and we also have some white papers there. And we have launched what we call an early access program. So it is the free trial of our software, which is announced shortly. It's announced this week. It's on our website. So if you see an interest in this, please sign up. Or if you're just interested in discussing this further, take contact with me. You have my contact details there. Thank you very much for my time.
Wonderful. Thank you so much, Åke. Well done. And as you noted, you are the last speaker, so please unshare this. Well, you can leave it there, actually. I think this was great. And with this, we should see if we have any questions for you. I'm checking my chat here. So I can tell you, I don't know if you know this, but are there any kind of collaboration between the different companies around here? Do you know that? Or I know you're fairly new to the company, so maybe that's an unfair question, but.
Yeah, we have had some not with the colleagues here today. We have not had, but I can see in the future several collaborations with the parties that are more on the sort of, could we call it the cloud part?
Yeah. Oh, but it is quite interesting when you work with a lot of companies like we do here in a similar space, and when you do that over and over again, and you really start to create an ecosystem by itself, which is very powerful. And I know Imagimob was probably the first one of the companies in Sweden working with Edge several years ago, and thus have been involved in several different collaborations and so forth. Let's see. Here comes a question. What about model lifecycle management, continuous improvement, etc.?
If I interpret the question a bit, if it's from a sort of business model perspective, or is it from a, if I take it from a business model perspective, since the model generated in our tools are owned by the customer when they're using it in our tool, it's also their IP, so to say, to further develop and maintain their model. When it comes to a more operational level, that's yet to be seen, I would say, because I focused a lot on the deployment side, because that's where we are in a lot of projects. We haven't yet seen so many Edge AI deployed products this far. We have a couple of commercial products out there, but it's yet to come. And I cannot really say what will happen in the future, but definitively this is another way of maintaining and further develop your product from a customer perspective. Earlier it has been hardware and upgrading PDM systems and things like that. Now it's about the data, and data is also an asset and should be put into the PDM and PLM system as such. And I think that the customers need to work a lot with always improving their data and their models, so to say. And the third aspect of this question is how to feedback and loop back and model into a better model. And this could, of course, be done by everything is connected, which is already is today. If you, for example, have a 5G or a 4G connection, you could very well download a new piece of software if you have trained it, but it is not error in it and so on. So I think that what we will see over the next years is a more automated feedback loop also in the edge, as we have mainly in the cloud. Without knowing exactly what was the question, I tried to angle it in this way.
I think that was great. So I'm the messenger. So I have another question for you. There are other lightweight edge AI solutions out there. What sets you aside from them?
I would focus a lot on that we could put in an AI model on a very, very small sensor. I mentioned a Cortex ARM M0, which has somewhere 30 kilobytes of RAM accessible. And we are using maybe 10, 15. And that's, we haven't seen so many companies that are focusing on smaller footprints. Many of the competitors out there, not Swedish company necessarily, but American and France and Israeli company, they have more of doing the data crunching in the cloud, and maybe are not focusing on finding a small footprint already from the beginning, and that's where we have focused. It's
Great.
not anything right or wrong, but that's our route to take it, and it's mainly for small cells.
Excellent. Okay, we have to stop there. We're running out of time. So let me just round off this to say that you have listened to 5 companies from across Sweden, which I'm really glad to tell you. Because, as I said before, Sweden is a tiny little country, and we just have to work together across Sweden. So that's a good point. And also that innovation and good companies are spread around quite nicely in Sweden. Secondly, they are all corporate-ready companies. They already have customers. They have customers abroad. They are already there, so to speak. You've heard about the expansion and so forth. And I think this is a really important thing from the enterprise side to think of, that you can waste a lot of time and money by going into clinch with companies who are too small or not ready to scale up. And I think we really drive the idea that we only work with corporate-ready companies or rookies, those who we believe will be corporate-ready very soon because they have good products and so forth. Typically for those companies, if you listen to think about what you've seen today, first of all, there's a lot of experienced people. No, this is not really youngsters coming out of school, very skilled in whatever. It takes very experienced people from business and from product and from sales and from everything to build those kind of corporate-ready companies. There has to be a lot of international experience and insight. We can't grow them, and stay at home. You just have to have an organization and the thinking which goes around internationally. And finally, you have to try with real customers and develop your product with real customers and not from your own head or your own idea or some theories in a book. So if you have all of that and you can figure out the way to reach the customers, I think they're ready to go. So I'm so happy and proud actually to give you those 5 companies today. So you will get a post-event mail from this with contact details to all those companies. And I urge you to take contact with them, or if you like, ask me. I can help you to get in contact with them. You also have a small survey there, so I'm really happy if you can fill in the survey, because that will help us to improve the format, the eBazaar format for the fall version, where we're going to show a lot of new events. And with that, thank you so much for your time, and I wish you all a wonderful summer. Bye-bye.